Hi, I'm Miss Hall.
Hi, I'm Ethan Hossager. Hi, I'm Isaac Hossager.
And this is lesson 39, Solving Radical Equations. Can you say that?
Radical equations.
Perfect. So as we wrap up season 5, I brought in a guest artist, a guest performer, my husband. This is Mr. Sajak.
Hi, everybody.
He teaches math at a different school. So in this lesson, we're solving radicals, and we're going to begin with what are the steps for solving a radical equation, and then we'll start solving them.
All right, so the first step, you're going to perform basic algebra, but to isolate the radical on one side of the equation if necessary. Step 2 is to raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or some other polynomial equation. You need to get rid of that root. And step 3 is to solve the resulting equation using techniques you've learned in a previous chapter. And make sure to check your solution. That actually becomes incredibly important because we'll get something that are called extraneous roots.
Example 1, solving radical equations. I'm going to take A. First thing I would do is divide both sides by 2. How convenient, that's what you wrote. So now we're left with the square root of x plus 1 equals 2. Oh, I've completed step 1. I've isolated the radical. Now I need to remove that radical symbol. So I'm going to take the square of both sides. Right? The opposite, the inverse of the square root is squaring. And now on the left side, I'll have x plus 1. And on the right side, I'll have 4. And now, subtract 1 from both sides. X is, really committed to these colors, is 3.
Making fun of me in my first guest appearance, I see.
Okay.
All right, so in letter B, the first thing we see, we want to isolate the root, in which this case is a cube root or the third root. But in order to do that, we need to move the negative 1 to the other side. So we'll add 1 to both sides. And we'll end up with the cube root of 2x minus 9 equals 3. Now, here we've isolated the root, so we need to undo that root. The opposite of the third root is raising something to the third power. If we do it to one side, we need to do it to the other as well. So we're left with 2x minus 9 equals 27. And from this point, you have a simple linear equation. Just as a preview, you could get many different polynomial equations here. Maybe we'll see some in the future examples, but I'm sure you know how to solve this by adding 9 to both sides here and getting 36, and then dividing both sides by 2 to get 18.
Okay, raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equations. These solutions are called extraneous solutions. When you use this procedure, you should always check each apparent solution in the original equation. And we're going to see an example of this in 3.
All right, so in example 3, we have a radical on one side of the equation. And we're going to show you just a different method for dealing with this in case it's not apparent. So we're going to rewrite that radical to the 1/2 power, right? The square root is the same as raising something to the 1/2 power. So we have that all grouped. And this is the reason why to undo a square root, we raise something to the second power. We're going to raise both sides to the second power. As you know with your exponent rules, a power to a power, when you do that, you multiply them. So Miss Hall is showing 2 times 1/2 will give us just 1, and anything raised to a power of 1 is just itself.
Right, so that's what it is, but you don't need to show that it's to the first power.
Right. And on the other side, on the left side of the equation, we have x plus 1 squared. We'll use the box method, or as my students call it, the boogie down box.
Fascinating. And if you don't need to show this work and you can go ahead and you're like, oh, I know that x plus 1 squared is x squared plus 2x plus 1. You don't need to show that box method. I'm just showing all the thoughts down.
Okay, so now we have a lot of terms here. This isn't a linear equation. The first thing to notice is that it's a quadratic equation and that Usually the best way to solve a quadratic equation is to make one side equal to 0. So we're going to move the terms 7x and 15 to the other side by subtracting both of them to get x squared minus 5x minus 14 equals 0. And hopefully your first instinct is to factor. So we'll factor this into x minus 7 and x plus 2, noting the signs are different because our last term, our c term, is negative.
Let's just say you can't see these factors. You just need a method that always works when you have a quadratic, and that would be the quadratic formula. It would take more steps because this is factorable, but you could always use it.
Sure. And then from our factors, we can get our roots because one of those factors has to be equal to 0. So we get x equals 7 and x equals negative 2.
Now these are the apparent solutions.
Yeah, so when we solve equations with radicals, we must check those solutions in the original equation. Because we know that sometimes square roots, we can't take the square root of a negative number. And some of these apparent solutions we get would produce a negative radicand. So we're checking our we're checking our solution of 7 right now to see that it's correct. We get 49 plus 15, which is 64. And 8 is the square root. It's the principal root of 64. So that solution is correct. So we'll keep x equals 7. But let's try x equals negative 2 and we'll see what happens. We get negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So we get that negative 1 equals the square root of 1. However, here, we only have the principal root because that's the way the original equation was written. So negative 1 isn't equal to the principal root of 1 as the equation is initially written. So we have to remove that as a solution to the original problem.
So this is the extraneous solution. You do not need to label it, which means there's no room for me to write the actual solution. It'll go up here.
X equals 7.
Okay, the radical is already isolated, and so I'm going to raise both sides to the second power. And I have 2x plus 7 equals.
Can we do this in our head?
Yes, x squared minus 8x plus 16. Now we're going to make one side equal 0. Are you going to show the work?
No,
what are you doing?
I'm just showing that this is a quadratic, so we do need to make one side equal 0.
Okay. No, 0 equals x squared minus 10x plus 9. Now let's factor, and we get x minus 9 and x plus 1.
X minus 1. Both signs have to be the same because the last term is positive.
Okay.
It's a good thing I'm here.
And now we get that x equals, I would have just re-recorded it, 9 and 1. You write it like that?
Yeah,
Do you put the and sign in the middle?
You don't have to, or you could write it like this. Actually, this way is better.
Okay, now I'm just guessing that one of these is extraneous because of what we were just doing.
Which one are we checking first?
Is there always an extraneous one?
No.
Okay. Which one are we checking first? 9, because it came first. 2 times 9 plus 7 equals 9 minus 5. No, minus 4, which is 5. 25 does equal 5. Looks good. Look at you go color-coded. 2 times 1 plus 7
I've done this before.
is 9. 1 minus 4. The same issue. We want the principal square root. So we get rid of the extraneous solution, which is 1. Therefore, the solution is x equals 9. What did you just do?
This popped up.
Okay, x equals 9. I'll just put it on the side. Finally, got it.
Finally, like it was my fault.